I'm Erin Hunter, Senior Editor at Livelong Media, and I'm excited to share my conversation with Dr. Jennifer Garrison. We're going to talk about the life cycle of the ovaries, everything female reproductive health, and how the goal really isn't to delay menopause. So thanks for watching, and be sure to subscribe to the Livelong newsletter. You say, I don't want to talk about menopause anymore. Please elaborate.
I guess I should qualify that by saying menopause is obviously an important part of the conversation, and certainly I have actively participated in helping to bring it to the forefront of people's attention and knowledge. Over the last 4 years, we did a huge media campaign to try to talk about what the downstream consequences of ovarian aging are. And I will say, 4 years ago, I definitely bookended the conversation with fertility on one end and menopause on the other. And, my thinking has really evolved on this point. And I think if we're going to talk about healthy aging in women, which is really what I care about, then we have to think about ovarian function across a woman's lifespan. And it's important for more than just fertility and menopause. Those are super important pieces of the puzzle. But if ovaries aren't working properly at any age, that uncovers different health risks that are specific to your age, your genetic risk factors, and your environmental exposures, like who you are as an individual. And so I think it's a huge misconception that we only need to think about ovarian function, when we're trying to get pregnant or when we're, at and approaching menopause. Does that make sense?
It does make sense. And similarly, I saw you had a quote once in New York Times or I don't know if it was your quote or another quote, but the ovaries are connected with every aspect of a woman's health to a certain degree. Can you explain what that looks like over the lifespan first, just to provide some color on what the ovaries are and what they do throughout our lives?
Sure. Yeah, I think about them, I call them now the architects of health in female bodies. So they are sitting at the center of a really complex signaling network. It's important that we don't cartoonize it or make it sound trivial because it's complicated, and I want to make it clear that we by no means understand how it's, like, what it's doing or how it's doing it. What we do know is what happens when ovaries aren't working properly or when we take them away. That's how we know what they're doing. And I think it's fair to say that even in girls as young as 10 and younger, ovaries are important for maintaining health. So in young girls, if ovaries aren't working properly, that might lead to issues going through puberty or could lead to things like irregular menstrual cycling. In women in their 20s, ovaries not working properly could uncover risk for things like polycystic ovarian syndrome, PCOS, or POI, primary ovarian insufficiency, or even POF, which is primary ovarian failure, which is when ovaries stop working and for reasons we don't fully understand in young women, and they go through menopause kind of overnight. It's very dramatic. And the medical community treats that like it's an emergency and sort of throws everything they can at it. But when that happens, exactly the same process happens a few decades later, we just tell women to suck it up. So there's a strange cognitive dissonance there that I think we should consider. Obviously, when ovaries aren't working properly in a woman's 30s, that can uncover risk for infertility and things like miscarriage, which we're much more familiar with. When ovarian function starts to fluctuate in a woman's 40s, that really, is why we have so many different symptoms associated with menopause, because in perimenopause, there are, we know a few of the words in the chemical conversation that ovaries are having with other tissues, right? We know a little bit about the hormonal symphony that's required to maintain menstruation and to promote regular cycling. That's important for fertility. But if the level at which we understand that, imagine that there's dozens of other hormones that are being produced by or sensed by ovaries that are important for all kinds of different things. And we don't know yet what they are or how they're working, but they're there. And so, when we think about ovarian function and health, I think we still have a lot to learn. And of course, at and after menopause, when ovaries stop working the way they were before, I don't say that they've failed, because I think that's a mistake. We know that ovaries do something after menopause. We just don't know what. It's certainly very different from what they were doing before. The reason we know they're doing something is because in women who are postmenopausal, if you take ovaries out, those women have poorer health outcomes than the women who retain their ovaries. So again, big open question what's happening there, but they're doing something. But when they stop functioning the way they were before, at and after menopause, that uncovers risk for things like cardiovascular disease, osteoporosis, cognitive decline, autoimmune disorders. I could go on and on.
So is the risk for all of these diseases, is the speculation that it's because of the hormonal symphony you were talking about that the ovaries conduct, if you will?
Yes, I think that's definitely part of it. I would say we understand so little about female physiology. I mean, full stop, step back from ovaries. We really have not studied the female system. We have a century of preclinical and clinical data that was collected primarily in males, both in basic research and in clinical medicine. The male body has been biology's baseline, and so you can't understand what you don't study. And women are not small men, and so we're just coming from so far behind in our understanding. We're at the very beginning. So with ovaries, we literally just, 4 years ago when we started funding research in the space, we funded some of the first single-cell omics large-scale data sets in mouse and human ovaries across aging. And since then, there's been a huge number of researchers who've started to work in the space. And yet, it was only a few months ago that we all got together and had, we called it a cell types jamboree, where we talked about ovaries, fallopian tubes, and uterus. And the topic of discussion for 4 days was just, can we all agree on what to call a cell type in these tissues? And the reason that's so important is because all these large-scale data sets, these huge multi-omics data sets that were being collected, we couldn't compare between them and across them because nobody had agreed on what to call a cell type. And so they were all labeled differently. And imagine if I told you that about your heart or your brain. You would be appalled, right? You would be horrified. You would be incredulous and think that's not possible. And yet here we are for organs that, are absolutely essential for health in female bodies. That's where we're at. So we're really just, I hesitate to say anything because we're really just at the beginning of discovery.
So that's pretty crazy to me because obviously, as you mentioned, we have so much science from hundreds of years, but it's surprising that just 4 years ago, we're studying stem cells, we're studying these things that everyone's like, oh yeah, longer life, this, but we don't have the terminology for just a thing that's part of our body for all of history.
Yeah,
to put that into perspective.
I hope, yeah, I to be fair, I think this is also true of all of female physiology. Ovaries are complicated as an organ, right? It's not like your liver, where if you were to slice through a liver, it's relatively homogeneous and you could point out the handful of cell types that are there. Ovaries are, because of what they do, they're so dynamic and, beautifully complex. And they go through these dramatic, huge remodeling, on different time scales. So they go through a remodeling that happens on the time scale of a cycle, so 26 to 30 days. So they physically, like macroscopically change what they look like. But then on a longer time scale, over a year, in fact, every cycle, there are about 1,000 immature follicles that are recruited to start growing. And at the end, the goal is to ovulate one of them, and the other 999 die through a process called atresia. So every cycle, you are losing about 1,000 follicles. But what that means...
How many do we have to start, if you don't mind me asking? Like, in general?
No problem. Human females make all of their eggs, or they're immature, but all of the things that will become eggs in utero. So somewhere around 26 weeks gestation, you had all the eggs that you were ever going to have, and that was somewhere between 6 and 7 million on average. And then by the time you were born, that number had dropped to about 1 million. This is all on average. And then by the time you went through puberty, that number had dropped to somewhere between 300,000 and 400,000. And then every time you go through a cycle, you are losing about 1,000 eggs. And, and also over time, especially during adult life, the quality of those eggs goes down as well. So it's not just the absolute number, it's also the quality. And then once they go beneath a certain threshold, that correlates with menopause. It certainly also heralds the end of your fertile window. So, you lost a large percentage of the eggs that you started with before you ever could have used them. Which is weird, right? Like, humans have this weird reproductive strategy that almost no other animal in the mammalian clade has adopted. So we're pretty strange that way. But, if you take a step back and think about it from the perspective of where you came from, like the egg that you developed from, I can talk about the egg I developed from. The egg I developed from was made in my mother's womb, so like in my mother's ovaries.
Based off of this, you're saying the quality diminishes as you get older. You start with them all when you're young, and you're basically losing 70% at birth. So in those first years where you've got quality eggs and you've still got a relatively healthy amount, what constitutes a healthy set of ovaries, and how do we know how that affects our health? What does that look like?
That's such a good question. You would think that we females would have some tools at our disposal to know what constitutes healthy ovaries, and also where you are on that decline, on that trajectory, right? Until we have the ability to change that trajectory, it would be nice to at least know where you are, right? Because one of the unique things about, we call it reproductive span, the period of time between when you start menstruating and when you go through menopause, is that it's really variable between individuals. So like your reproductive span and my reproductive span is going to be like totally different. And age at natural menopause can span almost a 14-year window and be called normal. And so like there's no other signature in human health that's so variable at the level of the individual. And it sure would be nice to know for, purposes of planning, for just thinking about how you're moving through your life, to know where you are on that trajectory. We don't have that right now. So there are some imperfect proxies we can use for ovarian health. So there's a couple of blood markers that will tell you things like how many follicles do you have developing right now. So AMH will tell you that, and that's important if you are thinking about fertility and are actively trying to get pregnant. There are non-invasive ultrasound. You can look at antral follicle count in real time. That will also tell you really about your fertility at this moment. There's a couple of markers that tell you, there's one in particular that tells you if you're within about a 1-year window of menopause. So when you're getting right up on it, There's a blood marker that changes, but I think if you're that close to menopause, you're almost certainly going to have at least one of those 135 symptoms of perimenopause, and you might sort of already have a clue that you're close. So there's just, there really aren't a lot of good ways to directly measure ovarian function. That's changing. I will say, the research has exploded in the last few years, and there's lots of really interesting things coming down the pipeline. But what I would love to see is a reproductive span, just an assay, just a roadmap, like something you get every year when you go to your OB/GYN to get a pap smear, that you would also get this reproductive span diagnostic panel, like a women's health panel. One thing I will say is that the markers that we know about and the things that we understand can change, your trajectory of aging in general, the things that we associate with aging in general. So things like diet and exercise, those things can also have a positive impact on ovarian function, at least as measured the way that we can imperfectly measure it. So right now, one way to think about it is that ovaries are aging. The pathways that they're using during aging are the same as pathways that are unfolding in your other tissues. The difference is that in ovaries, it's accelerated. So aging is accelerated. They're basically aging faster than the rest of your tissues. So our goal is to understand, to try to discover what is driving that accelerated aging, and not necessarily to extend fertility, right? The goal is not to end menopause. The goal is not to, enable women to have babies when they're 70. I think that would actually be a really hard problem to solve, because you need a lot more than functioning ovaries to have a healthy baby. But rather to extend the other function of ovaries, which is the endocrine health promoting function of ovaries, so that we can, preserve and extend female health span.
So in that respect, are the interventions that currently exist targeting the endocrine system? So secondarily, if you keep the endocrine system healthy, you're going to keep the ovaries healthy for longer, which is going to keep the endocrine system healthy for longer. And is that kind of where people's heads are at, or is it more
that's where my head is at, right? And to be clear, I'm really biased because that's where my own research lies. But we don't know what we don't know. I think, we have this consortium, the center that we started specifically to build the ecosystem around this area of science, because there was no funding, there were very few people working on it, and we thought that was a real problem. And until NIH and other large foundations catch up, we're filling a really important gap by funding researchers all over the world to work on this problem and trying to nucleate the ecosystem around them to accelerate translating their discoveries into women's hands faster. And I think we fund really broadly because we don't know where those causal, driving factor or factors are going to happen. Maybe there's multiple cues that happen at different times. Maybe it's something that happens early on. Maybe it's something that's happening in the brain. Maybe it's something that's happening, somewhere else. We just don't know. And so I'm biased because I'm a neuroscientist and I care and think a lot about the sort of the Wi-Fi conversation that's happening between the brain and the rest of the body, and particularly that brain-ovary axis of conversation. But that's just me.
So I have a question then, and you alluded to this earlier. Are certain dietary habits or lifestyle habits, which then are good for the brain if there is a neuro connection here, are certain things shown to slow down or delay menopause more than other lifestyle habits or choices?
I am unaware of any interventions of any kind that have been shown to delay menopause. That's not a thing. And again, I think using that language is really a mistake. We're not trying to delay menopause. Menopause is defined as the day on which you haven't had a period for 12 months, right? So it's really, that word is intricately linked to menstruation. I could care less whether you have a period or not. what I care about is, sorry, what I care about is preserving the endocrine function of ovaries. Now, if that means that we have to preserve your period, at the end of the day, then that's what we're going to work to do. But I think those two things are separable. And that's not to say that discoveries we make towards extending the health promoting function of ovaries won't have it. That almost certainly will have an impact on fertility. But we don't know. Those things, at least in humans and in animal models, are somewhat separable. The gap we're trying to fill here, which is one that I think a lot about because I work in the aging research space and I have had a lab in this space for 10 years, is that women live a little bit longer than men on average, right? Whenever I talk to men about this, that's the first thing they say. But don't women already live longer than men? Why do we care? Shouldn't we be working on extending male lifespan? And I'm like, no, you're missing the point. Women do live a few years longer than men on average. However, if they're lucky enough to live to old age, they're going to spend a significantly longer period of their lives in poor health. In that period of time at end of life, when they have one or more age-related diseases, and when what I call the period of decrepitude or morbidity. I know it's not a pretty word.
That's a bit of a. I like the decrepitude. That is a bit of a morbid term, but so we call that evokes the feeling you're trying to come with.
Yeah, I mean, in the longevity space, I think it's important to say, my goal is not to extend lifespan. I think there are people out there who are trying to do that, and I think it's great, really fun actually to have these intellectual debates. But in almost every animal model where we can extend lifespan, and there's plenty of animal models in research where we can extend lifespan, sometimes up to 20-fold, right? Imagine what that would mean for humans. Worms, mice, yeast, flies, monkeys, we can extend lifespan. But if you think about your lifespan as a fixed period of time, where for the first, certain amount of time, you're healthy, right? And then for that period of time towards the end of your life, you have one or more age-related diseases or, disorders. And we call that period of time, sick span or decrepitude, whatever you want to call it. When you extend the lifespan, those two periods of time, they scale. And so they both get bigger. And that's a nightmare scenario. You wouldn't want to extend your lifespan, but then spend a longer period of time in that unhealthy period of life at the end. And so my goal is to square off the curve. I want to extend health span first. Let's make people healthy until the day they die. And then we can talk about extending lifespan. Does that make sense?
It makes sense. And obviously you're coming from the angle of extending health span starts with figuring out what the heck the ovaries do and why they contribute to our health. It's finding out those aspects of it, because that's the part we don't realize, and that's the part that maybe is the missing key in all of this.
Definitely.
Yes. So then in regard to female health span, are you noticing anything now among older women who are healthier? That are they doing things differently? What actions are they taking to, in spite of the decline in ovarian function, continue to maintain that health span and low risk of cardiovascular disease and all these things that are attributed to potentially ovaries?
Well, I'm not aware of anything that would change your cardio risk profile beyond, the regular things like watching your cholesterol and taking statins if you need to. But in terms of what people can do now, for women at and after menopause, one of the major risk factors is osteoporosis, right? If you're not able to, or if you choose not to replenish estrogen after menopause, you are at extraordinarily high risk for osteoporosis. And that's not just about, your bones, it's about your risk of dying, right? For older people, getting a fracture, so breaking a bone, dramatically increases your risk of death within a year. and for a lot of reasons. So, to maintain healthy bones, you also need to have healthy muscle mass. And that's another thing that really diminishes as you approach and as you pass through and after menopause. So one easy thing that women can do now is to do like weight-bearing exercise, to lift heavy weights to exhaustion to build muscle. And I personally, because I am, I'm in the perimenopausal age, very close to menopause, I get DEXA scans, regular DEXA scans, because that gives me a really clean look at what my lean muscle mass is, where my fat is distributed, and what my bone density is. So those things I think are easy enough to monitor and easy enough to try to impact through diet and lifestyle choices like exercise and weightlifting.
Yeah, this raises a good point in my mind, because you're talking about risk of osteoporosis. So would you mind illuminating the top 3 or 4 real changes that happen during menopause? And even though we don't have the things that can necessarily stop the health span decline, can you list those symptoms and maybe what we can do to at least stave off how bad they could be, such as osteoporosis?
Osteoporosis is the biggest, I think. Cardiovascular disease risk goes up 4-fold after menopause, so that's profound. And a lot of women who had perfectly normal cholesterol levels will see them spike during perimenopause and after menopause. Autoimmune disorders go up after menopause, and risk of cognitive decline goes up. So those are maybe the biggest ones that I care about personally for my own health. And we don't have a lot of ways to mitigate these risks, right? I just talked about one that's important for trying to manage osteoporosis risk, but for all of them, the only things we have available right now to change ovarian function in any way are Band-Aids. And the best Band-Aid we have for menopause is hormone therapy, which got a really bad rap because of a study that was done, actually a paper that was published on a beautiful data set, published more than 20 years ago. That was, the message that was broadcast was just really inaccurate and wrong. And as much as there have been follow-up studies and tens of thousands of women have participated in studies that have shown that hormone therapy doesn't increase your risk of cancer or anything else, there's just a lot of misinformation out there. So I'm not a medical doctor. I'm a PhD scientist, and I do not give medical advice. So this is a conversation that has to happen between a woman and her doctor. And there certainly are contraindications for hormone therapy. But for most women, it's safe and really can truly make a difference, especially in, your risk for things like osteoporosis is very clear. The data is crystal clear.
When would people want to get hormone therapy? What's the best age range to consider?
This is also a moving target. Yeah, I will say, everything is, I don't want people to feel depressed after they hear this, right? It's not a negative message. There has been an explosion of not just interest, but also research in this area. And we are making up for lost time as fast as we can. There are huge numbers of studies that we need to do, but there's also a huge number of studies that are happening now. So it's all good. But we need to do those studies. We need to do more studies to understand when is it best to start taking hormone therapy. There were some studies done a while ago showing that the benefit is really best achieved if you start hormone therapy within a certain window after menopause. So if you started it more than 10 years after, there was some studies that suggested that wasn't going to help. But now there's new data that suggests otherwise. So I think, again, it's a conversation to have with a doctor, but there certainly are physicians that I've talked to who, and data sets that I've seen that are suggesting that starting it earlier is even, maybe even in perimenopause, might be something to consider. But again, it's, nothing about hormone therapy is perfect. It's one of these, I'll call it like a sledgehammer, partly because of this misinformation that's been out there for so long that scared women off of it. We haven't really innovated on hormone therapy since it was introduced. Like, it hasn't changed much. The one innovation that has happened is that we introduced the estrogen patch. So oral estrogen, just estrogen, oral estrogen can be metabolized by the liver into clotting factors, into things that induce clotting. And so, having a patch essentially allows you to get estrogen that bypasses the liver, and so mitigates all of those risks. Estrogen patch, most people take oral progesterone, although there's other ways to get it. If you have a uterus and you take estrogen, you must also take progesterone.
Why?
But to protect against endometrial cancer. So estrogen alone, estrogen alone, if you have a uterus. If you don't have a uterus, that's not necessarily, you don't need the combo necessarily. But, there's just a lot of nuance to it. And again, it's administered, there's not very many doses available. There's very few, it's just like a very simple cocktail. And I think there's a lot of, for right now, while we're doing the hard science to really, solve this problem in a way that's not a Band-Aid. While we're doing that work, I think that there's a lot of room, and there's a lot of companies now looking at how to optimize hormone therapy, maybe thinking about not just what's in it, but the relative amounts, maybe adding in other things, thinking through like really how to personalize it in a way that I think, because female physiology is so complex, I think that this is a place where personalized medicine is going to become so important.
That sounds amazing, and I want to be aware of your time so we can wind down, but I would love if you could share with listeners and viewers something that you would recommend or hope to see in the future of this research. And if you could say something to someone listening who does this kind of research, what do you want to see going forward? What kind of research, what kind of tools?
Well, we fund research in this space. We've funded 49 scientists all over the world so far. And, we need discovery-based science to try to uncover those causal factors that are driving ovarian aging, that are driving ovaries to age faster than the rest of the body. I mean, at the end of the day, all I want out of this is that we sync up aging in ovaries with aging in the rest of a woman's body. That's it. If we could do that, we would solve so many problems. And so the need is vast. We don't have great models for ovarian aging outside of humans. We don't have a really great understanding of how ovarian function changes with age. There's just so many things to do. And then on the clinical side, we need more large-scale data that looks at these relatively simple questions, right? We're not talking about rocket science here, but discovering new biomarkers, understanding the basis for a lot of these, they call them syndromes or disorders that are related to ovarian dysfunction, right? One in three women have health conditions related to poor ovarian function. And many of those conditions, like PCOS or endometriosis, those are affecting more than 10% of women. And they take, they're called syndromes or disorders because we literally don't understand what they are. It's probably a collection of different diseases that all present the same way, that have the same kinds of symptoms. And for many women, It takes years to get diagnosed. For something like endometriosis, the diagnosis procedure is an invasive surgery. That's insane. Like, we need a better way to do that. But then once you have a diagnosis, there's very little that doctors can offer their patients in the way of like true therapeutics. So, I feel like there's so much to do. And it's great that people are waking up to the idea that we need to fund this work. I'm in the middle of trying to, everything we do is through philanthropy. So we're trying to raise a whole lot of money right now, not just to fund new grants, but to think about for the grantees that we already have, some of whom are finishing their grants, what's going to happen to those projects? Normally in science, when your grant runs out, you pivot and you go find other funding to do something that's probably going to be a little different because you have to sort of structure your projects to fit the funding call. So what we'd like to do is set up a second track where we can have another pot of money that existing grantees or former grantees can apply to have sustainable funding, so that if they're doing something that's, we're asking them to take risks. We're asking them to do this like groundbreaking, paradigm shifting, like big science, not like incremental advances. And if you want someone to do that kind of work, you have to give them some sort of runway that's, longer than 2 years. So that's part of what I'm working on right now, because what I don't want to have happen is for all these amazing projects that have started to see them just stop or change because they have to go look for another source of funding that, has different metrics and different rules.
In order to make the change, people have to know it exists. They have to have the data and have enough time to show that things can actually help or change, or learning new things. It's not an overnight thing. Beauty and progress takes time.
It takes time.
It takes time. That's awesome. This is hopeful. Despite the decrepitude that we talked about earlier, I think all things considered, this is actually just more importantly, just raising the alarm that, hey, things are at least happening now, and we're going to continue making it happen despite the limited stuff we
Oh,
had
hell
in
yeah,
the
we are.
past.
Oh my God. Yeah. This is not okay.
Yeah, we are. This is Yes. Woo! Oh, I can't ask any more questions after that. Well, actually, one more, and it's unrelated. In 2017, you did a study about smelling and longevity. Can you just talk about a split second how on earth your nose contributes to longevity?
Oh, okay, yeah. So that was actually a review article. So I was reviewing studies that other people had done and also sort of speculating on how things might work. There's no question that your sensory systems, so smell is one of your many sensory systems, right? You have touch and you have vision and you have smell. Sensory inputs into your nervous system, into your brain, tap into all sorts of different circuits. So for example, like you have sensory cues in your mouth that tell your brain when you're drinking water, or will tell your brain and similarly with your nose, your nose, you can smell things that like when you smell something, that's like sensory information that's going into your brain to tell you something. And those circuits are all connected, and certainly many of those sensory circuits feed into places in your brain that control homeostasis, and those are the kinds of things that change with age. So the question is, can you link, sensory cues, including smell, to aging? And the answer is yeah, you certainly can. Now, there's nothing to say that there's a causal link there, right? Because when you're talking about things like this, you kind of want to know like cause and effect. Nothing I can say about that, and I haven't really thought about this for a long time. That was a while ago that we wrote that, and the person I wrote it with works on, like, his whole lab is really based on thinking about those homeostatic systems and how they regulate like your whole body physiology.
So I think at the end of the day, this just means, everyone, you have to stop and smell the roses because you don't know